Hello everyone, welcome to the chemistry guide. Now our topic is bond parameters. In this topic, now I am explaining about bond length. Firstly, what is bond length? The average distance between nuclei of two bonded atoms in a molecule is called bond length. For example, consider this diatomic molecule. Let the atomic radius of A atom is R1 and the atomic radius of B atom is R2. Now, bond length of these molecules is equal to R1 plus R2. So, remember that bond length is the distance between centers of two atoms bonded together. Next, bond length depends on electronegativity difference. We know that down the group electronegativity decreases. For example, consider these molecules. We can see that hydrogen is the common atom and bonded to all another atoms. This is the size of hydrogen atom. Then remaining atoms are halogens: fluorine, chlorine, bromine, iodine. We already know that in the group electron negativity difference is decreases. Hence, the size of the fluorine is small and the size of chlorine is little bit bigger. The size of bromine is more bigger and the size of iodine is biggest. We can see that hydrogen iodide is the biggest molecule. Hence, it has highest bond length, while hydrogen fluoride is the smallest molecule. Hence, it has smallest bond length. So, this is the order of increasing bond length. From this example, we conclude that bond length is inversely proportional to electronegativity difference. I mean, if electronegativity difference is increases, bond length decreases. If electronegativity difference decreases, bond length increases. Next, bond length depends on atomic size. We know that atomic size increases down the group. For example, consider these molecules. We can see that carbon, silicon, germanium and tin are the same group. Their respective atomic sizes increases down the group. The size of carbon is small. The size of silicon is a little bit bigger. The size of germanium is bigger and the size of tin is biggest. We can see that the size of tin is biggest. Hence, its bond length also largest. While the size of carbon is smallest and its bond length is lowest. So, this is the order of increasing bond length. From this example, we conclude that bond length is proportional to atomic size. Next, bond length depends on single, double and triple bonds. For example, consider these organic compounds. We know that this single bond contains 2 electrons. This double bond contains 4 electrons. This triple bond contains 6 electrons. Now, if the electron density is highest, bond length will be shorter. Hence, I write electron density is inversely proportional to bond length. We can see that this triple bond contains 6 electrons. It has high electron density and it has shorter bond length. While this double bond has 4 electrons or lower electrons density plus it has large bond length, while this single bond has 2 electrons, lowest electron density largest bond length. Hence, A has greater bond length than B. B has greater bond length than C. So, electron density is inversely proportional to bond length. Next, resonance. In this topic, you must remember one thing. Resonance is possible if there is pi bond plus sigma bond plus lone pair of electrons or free radical or vacant orbital. Let me repeat it. Resonance is possible if there is pi bond plus sigma bond plus lone pair of electrons or free radical or vacant orbital. Let's take this example. Here in this compound, this double bond contains pi bond, this single bond contains sigma bond and lone pair of electrons. So, resonance is possible in it. And this compound, there is pi bond, sigma bond and free radical. So, the second condition is satisfied. So, resonance is possible. And this compound, there is pi bond and sigma bond and vacant orbital is there. So, third condition is satisfied. So, resonance is possible in it. Now, we will learn the concept of bond length depends on resonance. So, order of bond length decreasing order is single bond, resonance structure have less double bond, then resonance structure have more double bonds, then double bond, then pure triple bond. Just remember this order, you can solve questions of bond length. For example, in this compound, there is sigma bond and lone pair of electrons. Hence, no resonance is possible in it. It is a pure single bond. In this compound, there is pi bond, sigma bond and lone pair of electrons. So, resonance is possible. Secondly, there is only one double bond is present in this compound. And the third compound, there is a pi bond, sigma bond and lone pair of electrons are present on this compound. Hence, resonance is possible in it. Secondly, there are three double bonds are present in it. Now, according to the rule, the first compound contains pure single bond, so it has highest bond length. And the second and third compounds resonance is common. Here we look at the number of double bonds. The third compound contains 3 double bonds. It means it has more electron density. Plus it has comparatively lowest bond length. Now the second compound has double bond and less electron density and it has comparatively higher bond length. Therefore, I write A has greater bond length than B, B has greater bond length than C. This is the order of decreased bond length.